this computer. Okay, for anybody listening to the recording, I apologize for starting it late. We talked about the migratory aptitude in the Beer-Villiger reaction, the carbon that's migrating. Here, this phenyl ring carries some positive charge, and that's what determines the migrating ability. But in some ways, you kind of have to memorize in part what it is. We talked about the Wittig reaction and how this transition state, it shows how the transition state lines up. Fools the molecule into getting the methyl and the benzyl on the same side. So it's a kinetic product, and it doesn't realize that until it's too late. When this phosphorus is a phosphate ester, or a phosphonium ester, they call it. Anyway, the phosphorus ester, then it's much more stable. This is reversible. Then it gives trans. Okay, and I warn people that a lot of students think that phenyl here, instead of the methyl, is enough to switch it to trans. It's not. But these reactions are very, very finicky, the Wittig itself. Sometimes by changing the salt you have in there, because you've used a bromide to make the phosphonium salt. And if you leave that in there, it makes a difference. If you remove it, you get a different ratio. These are tricky reactions in the lab. What I'm showing you is how they are put to their best use, the most common way of using them. Okay, was that it? I think that was what we did. That's a quick recap. Oh, and they asked just verbally, I'm not going to have you rank acids or bases on this exam. I wanted to trim it down, keep the exam short. And I know that, it's going to be a couple of years before students are really running well again. Justina, put your hand up.
Yeah, hi, Professor.
Well, a picture, first one today.
Hi. So I was wondering if you could go over a reaction from the textbook. It's the Grignard reagent being used in attacking a ketone. I can give you the exact page of the textbook if you want.
Well, my textbook's inside. Do I really want to go to in there?
Ah, okay.
Yeah, I can. It's not that far away.
Okay.
I'll be right back.
All right, sounds good.
As long as I disturb the doggy, I'll let her say hi. I'm not seeing me right now. Can you see her?
Yeah, I can.
Because I can't see what I'm seeing. So for those that haven't met her, this is Omega.
Adorable.
There's no clue you're there. Some dogs watch TV, not this one. Okay, I've got the 4th edition, but we should be able to make do.
Okay.
What edition do you have?
I think I have the 3rd one, so it might be a little bit different.
No, yeah, not that much.
Okay, so it's well, what I'm seeing is it's the conceptual checkpoint 19.30. For me, it's on page 874. I don't know if it would kind of be relatively the
Yeah,
same.
they're not that different. It's what number? 1934?
19.30. That's the react, like the problem.
That's within the chapter.
Yeah, but the actual page that it's on is 874.
Yeah, well, that's gonna be different. Conceptual checkpoint. You
Mhm.
guys know what they do when they put out a new edition of a textbook, right?
No.
They move at least one chapter, so the chapter numbers don't match anymore. And they rearrange the homework problems. And then they just make cosmetic changes more than anything to the rest of the book. They want to sell it again. And they want it hard for the professor to use the older version and the new version at the same time. It's evil.
It is. So the one that I specifically have a question on is like B, the one where you're adding a like Grignard reagent that has like a phenol.
Yeah, phenyl,
So
phenyl,
phenol. I'm sorry. I'm so sorry. I'll get it.
phenol and phenyl. You hear inconsistencies with that, so.
So to my understanding, like when you attack with a Grignard reagent, you're adding a new CC bond. But when I look at the solution manual, the answer has it where it's like there's another phenyl ring added or phenol ring. I don't know. Sorry, phenol ring added. And
Phenyl, phenyl, and phenol. You edit the emphasis in the right syllable.
okay. If it's okay, so if it's as a substituent, it's phenyl.
Yep.
Okay, perfect. Okay, so yeah,
Phenol is the white crystalline stuff that's dangerous when you melt it, but you put it in throat spray anyway. So this is the product. Is that what they have?
yeah, but I'm just confused because like where's like there's no CC bond added, like single
No,
bond
there's a
added.
CC bond. I'm looking for something.
Oh, right, sorry.
So
Okay, I see it now.
this is the new bond. So the
Okay.
anion on the incoming phenyl group attacked the carbonyl carbon.
Mhm.
So you're making a secondary alcohol out of an aldehyde.
Can you also go over like how they came up with the answer of C? I feel like that one's a little bit trickier.
C, well, C is ambiguous in my mind. Okay, so let's just do the simple answer. Okay, you've got the ketone here, but you've brought in a new phenyl group. And so after you quench it, you'd have that alcohol, but what about over here? Is that the answer they give? Or they give a different?
No, the answer that they give, they have a carbonyl on.
Yep.
Yeah.
Yeah, I know what they did. Yeah, and I agree with the answer the way they wrote it. But, you know, it would have been nice for them to give some emphasis. Like they could have said, where would they put two hydronium ion? They could put warm. Then you know you should do something else. So this I can't think of the name and you don't care anyway. This 5-member acetal, there we go, ketal, is a protecting group for a carbonyl. Oh, I'm sorry, I'm missing a carbon. Somebody yell at me politely. Okay, there's the product because it started out as a ketone. Now it's tertiary alcohol. So they added the Grignard reagent in here and you quench it with acid, you get the molecule on the left. But hydronium will hydrolyze the acetal now. Come on, behave.
Yeah, so I guess that's the part where I'm missing is
Okay,
why.
well, they've got it listed as 1 and then 2, the reagents. And I sometimes don't pay attention and do it wrong. And a lot of textbooks just don't care. But in most publications, if they say 1, 2, they're separate reactions. And an acid quench at the end of a reaction is not considered a separate action. It's considered completing the first reaction. And so if that acid were intended just as a quench, it should be A, B. 1, 2 should imply that, oh, what else is the acid doing?
Okay, so I guess I'm a little confused then on the addition, like where did the addition of the carbonyl come in from? And then why did we add another methyl group next to the OH?
What's the methyl group started here? So this methyl, oops. This methyl group. Is that what you're talking about?
Mm-hmm.
That's in the starting material. It's a methyl ketone. So that methyl group is just going along for the ride. It's a ketone becoming a tertiary alcohol.
Okay, so then I'm wondering, because I guess I'm comparing it to B, why was there not another methyl group added then?
Well, because that's an aldehyde. And so the hydrogen goes along for the ride.
Okay, got you.
You
So,
start with 2 groups on the carbonyl group, 2 alkyl aryl, 1 of them and a hydrogen, and whatever 2 groups there, they end up there on the product. Here, the 2 groups were alkyl, and so you end up with a tertiary alcohol. If this methyl instead had been hydrogen like B, you'd end up with a secondary alcohol.
okay, got you. All right, yeah. So there's just a difference between, yeah, because I didn't realize like in the textbook, they didn't really make it a difference between the ketone or the aldehyde. Like they just kind of made it seem like it would be the same outcome. And so that's where I got a little bit confused.
Okay, let me bring up my slide. And I still haven't had time to go through all the slides. Oh, you guys got to see this if you haven't. This is one of my favorite cartoons of the semester. I especially like the Irish coffee. Double espresso, that's me when I don't get enough sleep. It's near the end. Where is it? Okay, here it is. Okay, so at the very top here, formaldehyde and a Grignard or alkyl lithium, they react very similarly here, gives a primary alcohol. An aldehyde, and R could be AR. R usually means alkyl, but it can include aryl if I say it does. Aryl by itself is usually capital A, little r. So R is subject to definition. So R is anything, any type of Grignard here. Okay, so if you have an aldehyde, you make a secondary alcohol. If you have a ketone, you make a tertiary alcohol. So this is a comparison of the, well, 2.5 possibilities because the top one's hard to do in practice. Works on an exam. And then the bottom is using an ester usually. And it gives a tertiary alcohol with 2 of whatever reagent you used. Does that help?
Yeah, perfect. Thank you so much.
And then there's the one that everybody loves to hate. this one. So epoxides have reactivity that is in some ways like a carbonyl group because of the strain of the ring. It gives them unusual reactivity, but it is kind of an SN2 reaction as well. So this reaction lives in no man's land. Okay, so the anion will come in and attack the most accessible carbon and open up the ring to give you whatever the alcohol ends up. Here, this is a secondary carbon, it gives a secondary alcohol. So the OH ends up further away than with an aldehyde. With an aldehyde or a ketone, the new group would end up the same carbon the OH is on. Here, the new group ends up displaced by one. And most students find this tricky. It takes a little practice. You got to see it. Going forward is not quite as bad, but people have trouble going backward. I think there's some homework questions. Do that. Let's see. Oh, what I want to the next chapter. Oh, come on. There we go. I like this one too. I like all my cartoons. Okay, so the ether chapter is kind of a boring one. It's some review. It's a bunch of miscellaneous stuff, but the most important thing in there is epoxides. So here is what you have to know about epoxides. You really can't think of it as purely an SN2 reaction because first off, the ring is strained, and so alkoxide makes a fine leaving group because you're releasing ring strain, but these angles are screwed up. So this, what I'm showing as a tertiary carbon, is a lot more accessible than a regular tertiary carbon. And so this is a good, no, that's not what I want. Here's what I want. So if you hit this with a thoxide, thoxide's a hard anion, it doesn't need help, and it's going to open up where it can more easily find the carbon. So you get this regiochemistry, where the alkoxide kicked it over to the tertiary alcohol. But if you protonate this and then react with chloride, a much weaker nucleophile, the chloride won't be able to react at all unless it's protonated. If it's protonated, it puts partial positive charge on these two carbons, a lot more on the left, and this angle gets even more screwed up. Putting partial positive charge on here and weakening this bond at the same time kind of flattens it out even more. So chloride does an SN2 on a tertiary center, but not really. So this epoxides kind of live in no man's land. There's someplace, they're more like SN2, SN1, but they're a little bit like carbonyls. So yeah, you gotta think of epoxides as something different because they are. Now I have a real fancy explanation, but I don't know if the day before the exam is the right day for fancy explanations. Just remember this comparison.
Awesome. And then there's like one more question that I have. It's from 19.32. I got an answer to it, but it doesn't like exactly match. It's very similar, but doesn't exactly match the answer that's in the solution manual. So I was just hoping if
A or B?
B. Would I be able to draw out for you what I got and you can sort of show me?
Might be easy if
how.
oh, well, yeah, I can give you access to draw.
Thank you.
What am I doing? I gotta insert new slide, blank screen. I haven't done this.
I think there's a whiteboard function
Annotate,
on.
annotate.
Okay.
Yeah.
There's also a whiteboard function on Zoom, so I can just use that as well.
Oh,
If you-
really? I've never
Yeah.
seen that.
So if you just like give me access to like I
Okay,
think-
just allow you to be boss.
Yeah. I think you just need to like allow me to have like share screen function, and then I can share like a whiteboard.
Oh, I've got to cancel out of here. Oh, bother. Eraser. Or clear. And then get rid of this. And now I can select this. You have control, I hope.
Yes, I do. Thank you. Okay. We just change the color so you guys can see. Oh, okay, so that's what I got. But
Okay,
it's
I'm not seeing what you drew. Is it hidden?
Oh. Interesting. Okay. Let me, oh, I don't know. Give me 1 second. Let me see if I could like do something.
Yeah, Anissa, while we're trying to figure out this problem, there's only one question that's not from the 2 chapters, the aldehyde and ketones, carboxylic acid and derivatives chapters. I don't want to limit it more than that.
Okay, do you see this now?
See what?
I like shared something new, something else. I don't know if you can see it.
I see nothing new.
Okay, wait, okay, sorry. Let me stop sharing completely and then try this again.
Do you want to just draw on my slide?
Can you see it now?
Hmm?
Can you see it now?
Nope.
Ah,
I think you have to choose an option to view her screen. On top, I saw under view options, there are 2 shared screens with Professor Hammond's and Justina's. I think you have to select Justina's because I can see what she has.
Yeah, I'm not sure where to go.
maybe, Dr. Hammond, maybe if you stop sharing screen and then I'll share my screen because okay, perfect. Thank you.
Oh, okay.
All right, do you see it now?
It's a little ugly. Better than mine, though.
So that's personally what I got, but it obviously does not match what the answer is. So
Okay. So
just
the
if you can
first
fix
step
it.
is cyanohydrin formation.
Yes, which is, let me see if I can finish. Okay, so yeah, this
So
one.
draw the intermediate after the first step.
Okay, let me try to pull up a pen. Okay, so the first step was
Okay, now, can you see when I move my mouse, my cursor? No,
No,
'cause I'm not
no.
sharing.
But wait, I can give you like remote control where you can kind of use my.
Complicated for an old man. The carbon you have on the top left, in the carboxylic acid.
Yeah.
That came from the carbon of the nitrile.
Yeah.
Okay. You have one OH, which is here. How did the second hydrogen on the bottom structure become an OH?
Hmm. Give me 1 second. Let me just pull it up. Oh, sorry, I drew the wrong thing. Jesus, sorry.
Yeah, I'm saying yeah.
Yeah, I don't know where I got that from. I'm sorry. Give me 1 second to change that. That's supposed to be just a hydrogen.
Okay. Well,
wait.
is that the answer they give?
Let me just change that. So this was actually, it's not letting me.
Okay, but they gave the eliminated product?
Yeah, so they gave, this is
Yeah.
what,
It depends on how much you heat it.
so I just wanted to make sure that like it
Yeah,
wasn't, like my answer wasn't wrong.
there's ambiguous. I'd give you credit for your answer.
Wait, oh, okay. Okay, perfect.
Yeah,
Okay, just wanted to make sure.
it's a very difficult elimination because the OH wants to be a leaving group and it's going to want to put some partial positive charge next to a carbonyl group. So that's disfavored. So it makes it a particularly difficult elimination.
Yeah, I just wanted to make sure that I wasn't, because I didn't understand how they got their answer. So I just wanted to make sure like,
Nope,
Am I
nope, that's
wrong?
the problem.
Okay, awesome. Thank you.
You didn't go far enough or they went too far and there's no way for you to know.
Thank you so much again.
Oh, and now all my okay, I do not formally drop your lowest exam. Okay, I expect everyone to take every exam and do the best they can. And good luck on the final if you just skip the topics for one exam. But I understand that a student can kind of have a bad day. You know, I don't know, but your dog died the night before and you felt you had to take the exam anyway. Okay, so if a person has four very consistent regular exams and a bad day, I do what I call aggressive rounding, right? So if they had done better on that day, how likely would they have been to get a little higher grade? Okay, so I can't promise anything in specific until I see the grades and see the pattern. You know, it depends on which exam it is, right? So I do take all sorts of factors into consideration. If somebody is improving the whole semester, every exam grade gets higher, that catches my attention. I will definitely do aggressive rounding on that. If somebody has a bad final exam day, that's tough to accommodate because the final exam is really the only measure I have of the quality of your learning, not your ability to cram the night before, right? No way you can cram efficiently for the final exam. The best you can do is review and maybe strengthen a topic or two. So the final exam tells me if you've been learning things as you go to remember or just short-term learning. And your grade actually should reflect the long-term learning, not the short-term learning. I don't think I've mentioned this to anybody this semester. Just to illustrate my attitude, I would love to give you guys your final exam in 1 year. I show up at your apartment. I say, today's the day, sit down, here's your final exam, a year later. Okay, now it would have to be a very basic exam. I'd have to write a very considerably easier final exam. But you know, I still would love to do it. It's just absolutely not practical in any way, shape, or form. But you do get my point. Yeah, Nafisa, those are not the grades that Francesca posted. I have improved the grades, especially the lower ones. She wasn't sure how to do the curves the way I do it, so she was happy that I did that. So they're curved the way the first exam and the rest exams will be curved. It's consistent with the syllabus. And no, I do not curve final averages. I curve the exam scores. I don't need any more curve after that. Tamika.
Hi, Professor Hammond. I have a question on the aldehydes and ketone homework, number 3, where we had to rank the compounds for activity.
Oh, sure. Let's go to that. Oh, here we go. Okay, well, this question or any version of it is not on the exam.
Oh, okay. But I still wanted to know.
I hope you still want to. Even if you don't want to, you should lie to me.
My question was between 5 and 4. That was where I was a little confused because I thought
Well, some of these, this is homework. I can be meaner on a homework than I can on an exam. So there's some more difficult comparisons here.
So I originally thought that it would be the opposite. So the acetophenone, the nitroacetophenone would be 5.
If you put 4 and 5 on your homework, I'd still give you full credit.
Okay, so then what was your, because I see your reasoning with the aliphatic aldehydes being more reactive, but I thought because a nitro group is electro withdrawing, it would make the carbonyl carbon more positive.
No, it's trying to pull electron density closer to the nitro group. So it's trying to put positive charge on other places on the ring. So you can see my pointer, right?
Yeah.
So the nitro group is going to pull lots of electron density out of that carbon.
Right.
By induction and by induction. It's going to pull electron density out of this carbon a little bit by induction, mostly by resonance. Okay, so the resonance impacts this carbon, this carbon, this carbon. So the resonance of the nitro group is trying to put partial positive charge here.
Oh.
That's going to destabilize this and make this a little bit more reactive than acetophenone itself.
Right. Okay.
Okay, so 5 and 4 is a very difficult comparison. I would not bet any money on my ranking.
Okay.
It's my best guess, and I could not defend it well.
Okay. And then my next question on that homework was number 10D. For converting the carboxylic acid to the aldehyde using reduction of an ethyl ester. No, yeah. No, sorry, that's E, the reduction of the corresponding nitrile. That's what I had a question on. I see here that you had, so I tried to reduced it down to primary alcohol, then to a bromo. So I used an example. Mine was butanoic acid, and then I reduced it down to butanol as my carboxylic acid. So
What steps did you do? You went through the ester?
No, this is for E, reduction of the corresponding nitrile. So I went through the primary alcohol.
How did you make the primary alcohol?
I used LAH.
LAH gives from the bottom left here?
No, from the carboxylic acid.
Oh.
But I didn't use that. I didn't use that acid. I used.
You made an aldehyde 1 carbon bigger?
With LAH from the carboxylic acid.
Okay, tell me what you did. You reduced it to the
So I didn't use that carboxylic acid. I used a just butanoic acid, just a simple chain. And then I reduced it down to a primary alcohol using LAH. And then I put a bromide on it with PBr5. Use NaCN to make that cyano.
Okay. Okay, and then you reduced it?
Yeah, then I reduced it to the aldehyde.
Yeah, you made an aldehyde 1 carbon longer.
Oh.
To the aldehyde. You know, if I had been more specific here, I might take some credit off, but the way I worded it, I'd give you full credit. Convert it to the corresponding aldehyde would mean the same number of carbons.
Ah, okay. So
and the way that you're interpreting is convert it to an aldehyde. So my verbiage implies the same carbon count, but
so that was my
not as clearly as it could.
So my goal was actually to make it to the corresponding aldehyde. I'm not sure which step I added the carbon to.
When you add the cyanide to the bromide.
Oh. Oh, okay.
That's okay. You absolutely showed me you know the chemistry. Okay. And because I wasn't specific enough on a homework or exam, I'd give you credit.
Got it.
If I put the word corresponding aldehyde here, I might still give you full credit. Depends on how good a mood I am grading the exams.
And so instead of NaCN, would I have had to use POCl3?
Well, the way that I did it here, is one way to do it. You somehow have to make the amide to make the nitrile. Okay, there are other ways to make the amide than what I have here. There are other reagents to make the nitrile, but you have to convert the carbon at the heart of the carboxylic acid into the C triple bonded to nitrogen.
Got it.
Okay, what you did is fine. That's a very useful transformation. If you want a nitrile 1 longer, you did it.
Okay.
So you got good practice.
All right. Yeah, these types of problems are the ones that I tend to spend a little bit more time on, because it's trying to figure out how to maintain this right amount of carbons and switch out the
Yeah, you know, whether I take off for that depends on the point and the complexity of the question.
Okay.
If you don't quite do it right, but you showed me you understood all the actual chemistry, yeah, at the most, it would be a small deduction.
Got it.
And again, if my wording wasn't as clear as it could be, my fault, you get full credit.
Okay.
Yeah, when somebody makes a mistake, I don't expect that way. I go back and reread my question and I say, I know what this means, but how are they reading it? So I always leave the possibility open that what is clear to me wasn't clear to novices.
Got it. Oh, and also, I know we have some synthesis questions, I'm assuming similar to this type of problem. And you said that you'd be giving hints if we're really struggling. Is it going to be the same
it's kind of like this and kind of not. You'll see what it is. I don't like to reveal my exams too much
Okay.
in detail. I don't want an absolute shocker for you when you sit down, but I don't want you to say, oh yeah, I studied all this stuff because I knew all this stuff was going to be on here. Something in between. So
Got it.
yeah, there's a scheme that I give you one single starter material and say, do this, what's the product? Do this, what's the product? Do this, what a product, in one chain. And so there are kind of hints from future reagents that you can guess what the function group is by going backwards instead of forward. But if somebody gets absolutely stuck early on, yeah, I want to give them a chance to earn some credit. What I did last time is simply if somebody says, I'm stuck, can you write down this structure for me? I write it down in my color and you don't get credit for it.
But it's not like
There's no penalty per se.
Okay.
You just don't get credit for the answer I draw.
right, okay. That's what I wanted to know.
I'm not that nice.
Okay, that's all the questions I have for now. Thank you.
And I realize some of my students think I'm really nice and some of my students think I'm the spawn of the devil. Well, thank you for the good questions.
Oh, I had another question, but it's for the carboxylic at the acid and derivatives homework.
Oh, I got the file, the folder open. Which one?
It's the third one. Wasn't sure what that last structure.
Down at the bottom right.
Yeah.
Big parentheses, two of them attached to the same oxygen. That's a symmetrical anhydride.
Oh, okay. Okay.
Yeah, thanks for asking though. It is a little fancier way to draw it, I guess. More concise.
Can you use that method of drawing molecules for anything that's a symmetrical molecule?
Yeah, most commonly was, I don't want to. You know, you can use it for CH3, CH2, CH2, parentheses. Oh, I'm sorry. CH, parentheses, CH3. It's no different than that, except I don't know why it turned off my subscripts. Can't get it go back on now. So here I'm showing two methyl groups. Oops, I forgot my final two. So here I'm showing two methyl groups. It's the same intent.
Got it.
Okay. Here I could put I could write that if I wanted to.
Mm-hmm.
Two paramethoxyphenols. Right. So you can do however complicated as you want to. If it gets complicated enough, yeah, you're going to want to draw it out like one you just asked about. Like this.
Got it. Okay. Thank you.
Okay, this is the homework without the questions. Oh, without the answers, I should say. And I'm looking to see about these schemes. This scheme is showing you all the products and asking for the reagents, except down here. So it's the bottom here, the way I'm asking it on the exam. I give you one structure, do something. Okay, take that and do something else. Okay, take that and do something else. It's that. This is kind of mixed and match. But the question on the exam all starts from one starting material and then a bunch of reagents. Okay, it looks like we're winding down. We got four of you still.
I have another question about what you just mentioned. Will it, I don't know if this is digging too much, but will it be all the same conditions, or is this kind of like different reagents that you'll be giving us?
It's like, yeah, I mean, each step is different reagents doing different chemistry.
Okay.
It's actually a way to put a multi-step synthesis on the exam without it having be a retrosynthesis or a planned synthesis. You know, I do the planning, you just got to fill in the structures. There are no more questions. I actually have another important meeting on my computer today. I'm going to have some FaceTime with my granddaughter.
That's exciting. I don't have any more questions.
Yeah, it was supposed to happen a week ago and it never happened. I got stood up by my granddaughter. Well, maybe I should blame the mother.
I hope you enjoy your call.
Always do, but you never know what kind of mood she's going to be in. And she plays games with me, my granddaughter. When I'm down there, I'll ask for a hug and she'll kind of shrug and sneak away. She talks about me when I visit and I'm not there. She seems to really like me, but she likes to tease me.
How old?
How old? See, 21 months, 20 months.
Oh, that's the exciting age.
Every week is different at first. Every month's a new adventure. Raising kids is fascinating. It's kind of hard work at times.
It's the fun part of being an aunt. You just kind of, you give them back.
Oh, this one's smelly. Here, it's yours.
Precisely.
I do actually just have one more question.
Absolutely. That's why I'm still sitting here.
Can we go to 19.11 in the textbook?
Boy, you putting the textbook into great use. You're the kind of student that would hate it if I didn't use a textbook.
It is very much a guide for me, yeah.
Yeah, I mean, I would always have a recommended textbook, even if it weren't convenient for me. I'd have to say, you know, we're going to talk about things from this part and this part and this part, because I want to change the way Orgo 1 is organized.
Yeah, I think for me, like, because I took Orgo 1 such a long time ago, it's been like helpful to like, I have the textbook and it's like the whole textbook. So I could just, and like, they usually put like little notes too, where it's like, oh, if they're introducing a topic that they talked about before, they'll be like, oh, check out like 6.11 or something like that. And that's like really helpful for me.
Yeah. Yeah. But what I think I described to some of you before, what I want to do is start with methane, talk about structure and bonding,
Mhm.
go on to ethane, keep adding carbon, start talking about isomers, do a free radical bromination. So now we have our first reaction. At some point, I'll get to elimination. So I'll have an alkene, new functional group. At some point beyond that, I'll have free radical bromination and I'll say, hold it. Something's different here. Something special about the system. Resonance. But I'm only going to teach that example of resonance, nothing
Mhm.
else. Okay. And then we're going to go on. Eventually, we're going to have, oh, hold it. There's something special here. It's resonance. Remember that? You saw something a little like this. And once we've had maybe 3 different examples of the types of resonance, then teach the concept.
You know, that actually sounds like a pretty good idea because I remember like for me, like isomers is still something that is like a little bit troubling for me and like usually takes a long time for me to figure out. Because when I took Orgo 1, like isomers were kind of like just touched upon slightly and then we like kind of moved on. I feel like kind of the way that you just described where it's like breaking it down like that and like introducing, I think you're bringing up these topics, but in like a very relevant way. It's not just kind of like, oh, here's a new topic, let's go over
In
it, but you don't know how it
context,
connected.
I
Yeah.
want to keep a context flowing.
Yeah.
And
Yeah.
also, what is a concept? In high school, they don't teach concepts. They teach you to memorize definitions of concepts.
Yeah.
And then they teach you procedural ways of solving the problems that don't really involve understanding the concept.
Mhm.
So yeah, it's a great disservice. A concept is how you connect knowledge in your head.
Mhm.
So you know this and this and this. Hey, there's a pattern there. So now you connect those different things that you didn't really quite think of as being examples of the same thing. So you've got to learn a few examples first and say, hey, by the way, there's a concept behind all this. It's resonance. And then people should be able to get resonance a lot easier. I hate the modern books. They say, here's everything you need to know about resonance for the rest of Orgo. Good luck.
It does not connect. Yeah. Context is
No.
actually important. Yeah.
Yeah, so you got to kind of warm up to some of these things.
I will say I'm quite jealous of students that took you for Orgo 1 and now get to like follow up with you in Orgo 2 because I feel like again coming from like a background of Orgo 1 where like things were just kind of like given to us and like we just had
Oh,
to like
I've
make
taught
do.
Orgo 1 the same way it's organized in the textbook up till now. Last semester was the first time I taught the large Orgo 1 class. In fact, it's the first time I've taught all of Orgo 1 as a class at Hunter. I've
Mm,
had split lectures. When you have a split lecture, you don't play with how it's done, right? You just go along.
yeah.
So yeah, I want to try that, getting ready for it's the problem. It's kind of like redoing all my teaching plans for Orgo 1. And the other complication is I have to finish Orgo 1 at the same spot that we finish now, because they might take somebody else for Orgo 2.
Okay.
You have
Yeah,
to
I got
decide between Orgo 1 and Orgo 2, the same place for everyone who teaches them.
Mhm.
Okay, which question?
Yeah, so it's B. I'm not really sure what to do with that one.
The exact same thing you could guess, ignore the 4-member ring.
Okay, but there's no carbonyl there. So
Oh, you're making a carbonyl, just like you made a carbonyl out of A. It just doesn't happen to be cyclic. It's a dimethyl ketone.
oh. Okay, so the protecting group is still there, but just kind of like in a more sneaky way.
Well, in a simpler way, if you will, the rings tend to bother some people, but some people think that they really help with acetals like you do.
Yeah, yeah.
Yeah. And by the way, B is going to be more or less reactive than one without a 4-member ring.
Oh, you're asking me?
Yeah.
Um,
Want me to do the Socratic thing?
yeah.
So what's the key intermediate in the mechanism?
The key intermediate.
Yeah.
So It would be
It starts out by protonation to make it into a better leaving group.
in terms of like, do I give you like the reagent that I would
No, no,
use?
just the names. You protonate the methoxy group and then methanol leaves. And that gives you an oxygen stabilized carbocation, right?
Mhm.
So that carbocation used to be sp cubed and now it is
Would be squared.
sp squared. It
Yeah.
has to be, or it can't have resonance with the oxygen just helped out.
Mhm.
And does that 4-member ring want an sp cubed or an sp squared carbon? You got to think of bond angles now.
I would say it wants an sp cubed.
Yep, it does not like having larger bond angles. It already thought 90 degrees was unreasonable.
Mhm.
So that's going to slow that down. That's going to be unusually stable for an acetal.
Okay.
Doesn't mean you can't beat it and do it, but you know, I don't like it when they have an unusual example of that without comment.
Yeah. Yeah. It definitely like threw me off for a
There should
second.
be a parenthetic below it says, oh, by the way, this reaction will be unusually slow. What?
Yeah.
Just tease them with a question. Let them think about it.
That definitely would have been helpful. But yeah, thank you so much for your time. I really appreciate it.
Yeah, I'll do this every Sunday. It makes sense. And I have the availability.
Awesome. Awesome. Have fun with your granddaughter.
Yeah.
All right. Have a great day.
Just a minute. Just a minute.
Oh,
There we go. Can you see it? I don't have my picture.
aw, yes. She's so adorable. I can like,
A little
I saw it
dark.
at first. Yeah. I saw it at first.
Oh, it is. It's very dark.
Pull it like back. Yes. If it's like that.
That better?
Yes, yes, yes.
Now that's
Wait. Yeah, there you go.
the little data. I mean, I have pictures of my computer, but I don't know if you want to sit there while I find them.
No, she's so pretty.
I'm sorry. Can a grandfather brag? Of course I can.
You can, of
He is
course.
so smart. And it's the smart kids that are hard to deal with.
Yes, yes.
So,
Very much.
payback.
I wish my dog was near me. You showed off your dog earlier. I wish my dog was near me so I could show him off right
How
now.
far away? I can wait.
I think he's. Oh my god. Oh, I accidentally scared him.